Hi everyone, I'm Philipp. I know I'm between you and lunch is serious in France, or food in general. I won't be long, don't worry. You will get food in due time. Um, I want to talk a bit about like what is happening to your systems and how you can keep track of what is going on. So oftentimes we see ourselves like this, and we often say like, "Oh, this is fine," and we don't see anything, and we'll just wait this out, and we don't know what is going on. Unfortunately, sometimes stuff doesn't improve on its own, and then you end up with something like this, when you're like, "Oh no, everything is on fire and everything has been terrible." So that happens every now and then. Um, and we don't want to get there. And from a scale from terrible to an okay security incident, I always have like these layers where I say, the first one is you learn stuff from the press or from your users, and that is going to be a very bad day. Kind of equally bad is if you have like somebody asking for ransom. For example, they have taken all your data as ransom, and then, yeah, unless you pay up, you don't get your data back. It might get slightly easier if you just have a very high cloud provider bill. So if you're on AWS and somebody gets your credentials, they might start mining Bitcoins, which is not very efficient, but since it's your bill, you can totally do that. Don't be there. I've been there. It is not a fun day if you get that bill. Sometimes you find out yourself, but after the fact, because everything has kind of like your data has been stolen, you learn it yourself, you try to mitigate it, but it's still kind of too late. Sometimes you find out, but you're unsure what has really happened. And the ideal use case would be you find out yourself, but you know that nothing bad has happened because you can prove it, because you have traces of whatever has been happening to your system. And that is kind of where we want to go and see that we can prove what has been happening to your system. So obviously there is no silver bullet because, well, in IT, luckily there are no silver bullets because otherwise we would be out of a job sooner or later. I would want to show one possible way how to keep track of what your systems are up to. If you have any questions, and if you're forgetful like me, you can just ask during my talk, and I will get back later to the questions. Also, if you don't want to ask like publicly, you can just write it down. Go to Slido and my Twitter handle, and there you can just type in any questions. We'll probably have time at the end, so I can just take them from the page afterwards. If I don't have time to answer them at the end, I will just tweet out the answers afterwards. So if there are lots of questions, I might not get to everything. Remember Slido/my Twitter handle, and that's where you can just post any questions. Whatever comes up, just ask, and I'll try to get to it at the end. Okay, so let's dive into it. I want to talk about Auditd and how to keep track of what is going on with your system. So it has its own GitHub page. It has a kernel module for kind of the actual dirty work and a user space module or modules to actually interact with what has been collected. It doesn't stop anything bad from happening. It's not like SE Linux or anything. It doesn't block anything, but it keeps track of what is happening in your system. And it has actually a lot of things it can monitor. It can monitor, for example, file system changes or lots of other things. This is the man page describing what it is doing. And I'll just show it in action in a moment. Things that it's doing is like watching files, monitoring system calls, recording various security events, for example, if you run sudo or whatever, specific commands the user has been running. So it's just watching over any security related events and monitoring those. I'm not sure if I am to blame or my headset. I'll try to wiggle it. Maybe like this? Closer? Like this? Like this? Okay, thank you. I I hope it's understandable for everybody. Maybe it's just my terrible German accent. Um, but yeah, this keeps moving around. I'll try to speak slowly enough that it's understandable. Okay, so this is what this is doing. Generally, the idea is you have your application, you run your application, you have in the kernel, you have the system call processings, and then you have an exclude list afterwards. And something that passes the exclude list will then be logged to the audit daemon. So whenever a user does something, runs a task, or something exits, these are events that can be collected with Auditd. And these might all collect security relevant events that you want to keep track of. So this is the general architecture, though I don't want to dive too deep into the internals here. Instead, let's try to do something live. And, well, this is not what I want, because we'll probably need to mirror that. This is much better. Okay. Let's see what we have here. So we have a standard Ubuntu system with Auditd enabled, and the first thing I want to run is an report on that one. And here basically you can see a general report of what the security events have been collected on my Ubuntu system here. So for example, you can see how many failed authentication requests we've had, how many users we have in our system, how many hosts, executables, and other things. This is just the overall view of seeing what is going on here. This is all based on specific logs, which you can see here in var less audit, var log audit.log. And well, if you miss less or something like that, you won't see much. Okay, here you can see these are all the events that we have collected. What we'll come to later on is that these events are containing all the relevant information. The main problem with them is that they are very hard to parse. So if you want to centralize them and extract any meaningful information from that system later on, that will be kind of a challenge. We'll get to why and how we have circumvented that later on. By the way, where we have configured the entire thing is in sudo ls in etc audit. There you have, for example, audit rules or a rules.d folder where you can specify your own rules. If you want to know like what rules you could add, and if I find my right window, here in their repository, they have a lot of example rules which you can use. For example, if you're interested in what you're doing about containers, because everybody is using containers nowadays, you could log specific container events here. So anything around containers, you could just watch the security of that. The syntax of how you log is kind of a bit arcane and not that nice, but it gets the job done. So you can just get the examples there and then apply them and see where you can take those. Okay, so that was Auditd and what Auditd is starting with. I have the link for the rules, and there you can look those up. So kind of the idea is to log and monitor all the things that are security relevant here. The problem is running that on one system is kind of easy. Centralizing that is kind of a challenge that is getting more interesting. Because, well, sitting on one host is not going to do you much good. So the idea or the problem is, how do we centralize all of that information into one place? So why do I talk about that? I work for Elastic, the company behind Elasticsearch, Log/Kibana. Beats, I'm part of our infrastructure team, so I do stuff like internal tooling. And I always say in the middle, that is a Unix pipe. I kind of pipe that out into developer advocacy. So I also speak about the good stuff that we do or try to do. So I kind of build highly monitored Hello World applications. And I will try to show you one or two security events that we can monitor with our highly monitored system here. Just to give you an idea of the stack, so we have the beats, which are like lightweight agents or shippers. They can collect lots of things, including, for example, the log files from Auditd. We have logstash for parsing information, though in our example we don't even need it because we just have very simple parsing rules, which we can do in Elasticsearch. Elasticsearch is generally storing your information, and then Kibana is there for the interaction. And the basic idea is that you have the beat to forward the information from all your hosts and then store it centrally in Elasticsearch, and in Kibana then visualize what you have in your entire system. Okay, and maybe you have used or heard of the infamous ELK stack, Elasticsearch, Logstash, Kibana. However, for security events, that's not that helpful because nobody wants to collect that with Logstash, because Logstash is a very heavy tool, or maybe heavy is the wrong word. It's a very versatile tool, but it started off as Ruby and is now JRuby. So you would need the JVM on all your servers, and very few people want to do that. So we tried to extend the ELK to something we now call the ELK-B or the BELK. And you can see this is the BELK or ELK-B because we've added the beats. Something like this. And this was the additional logo we wanted to use. However, in the end, our marketing decided that this won't scale because we always try to make stuff scale. And even marketing figures out that stuff needs to scale. And this is not scalable because if we have more products later on, we will need to rename and rebrand that. And then we'll need to come up with another animal. And it won't get easier to find animals if we have more letters. Whatever other letter we will add later on will make another animal very complicated. So now we just go the boring route and just call it the Elastic Stack to collect all of that information. It's just all the open source components to collect as much information as possible. Yeah. All Apache 2 license, so you can use it, change it, do whatever you want with it. All the stuff I'm showing you today. So, the first thing we tried was to centralize Auditd is just collect that Auditd log from the disk. And for that, we have created an Auditd module. So what we have here is, just to give you a quick idea what we have, filebeat, YAML. Basically what I'm telling my filebeat, so filebeat is kind of a component to collect log files. I always say it's like tailf on steroids and over the network. So it's basically just listening in on files and forwarding them to Elasticsearch. And one of the modules that we've added here is Auditd. So it can just collect the Auditd log file, take that and forward it, and we parse it. The parsed file looks then something like this. So if you've never seen Kibana, this is Kibana. Let me make that slightly larger. This is Kibana here. And we'll head over to some pre-built dashboards to see how stuff is working out. That is not the one I wanted. For example, for FileBeat, we have all these FileBeat modules pre-built for a lot of existing systems. And one of them is Auditd. So for that one, we are just tailing that Auditd log file. I didn't have like any violations or anything in the last hour. Let's see. I did do some stuff in the last 12 hours, so then you should see stuff. You can see which users have been doing something, what events they have caused. You can see where they have caused their events and when we had the most errors or successes. So here, for example, you can see we had 2 or 4 failures and 26 or 180 successful events. This is basically just tailing that Auditd log file, parsing it, and then extracting as much meaningful information from it as possible. So for example, you can see what kind of events we have collected. We get the map here for a GeoIP lookup, which funnily enough seems to come from, let's see, where does it come from? It doesn't seem to come from France. Any idea why my data seems to come from Austria? No, it's not a VPN. So I'm from Austria, and I'm using my phone. I just tethered my phone, and the GeoIP lookup normally for phones is very local bound. So if you're tethering your phone, your GeoIP lookups normally will not be very good. If you use a local IP address here, the GeoIP lookup would probably be better, and you could see it's coming from France. But that specific one, well, the location is a bit off this time because, well, of my phone. But otherwise, you would see where the events are coming from. And then you can basically see all the events that have been happening here. However, the problem was at some point we figured out that parsing the Auditd log file is kind of a pain in the ass. And we don't really want to do that. And we wanted to have like a better way forward to get that those informations and events. So what we did was we rewrote the Auditd functionality into its own beat. So we have something like, it's like a security beat, but we call it audit beat. And it does use the Auditd configuration syntax, but it has some other bells and whistles, and it doesn't write out in this weird file. It just logs directly to Elasticsearch. So it does some stuff like it can correlate events, it can resolve the user IDs, it can natively write to Elasticsearch, and we don't need to parse a file that is kind of wonky. We find it kind of easier to configure, and if you've ever looked into eBPF, which is also kind of fancy to trace any kernel events, eBPF is nice, but it requires rather new kernel versions. And with the Auditd module, that's not required. So that's kind of our fallback, how we can do that on CentOS 6 or whatever your operating system is. Pretty much any kernel version you have will work. If you're asking, how will this work on Windows? Unfortunately, it doesn't, because it's a Linux kernel thing. We don't have that for Windows. The other nice thing is I have that running on the same instance now side by side with Auditd. So while I have some rules running in Auditd, I have the same plus others running in Auditbeat to collect all of that information. So let's see what we can do with that. Just to give you a quick idea what we have here. So let's head over to the overview. So you can see I have changed my configuration approximately this morning to collect more events. You can see what we have collected here. For example, you can see how many users are logged in at one point in time. And then you can see where my rules are coming from and which user is doing what security related event. For example, www-data, the Nginx user, has unset some connections, which we have collected here. Or root has been running some things here. Okay, so that is the general overview. Let me quickly cheat to see what I wanted to show you. First off, let's head over to the Auditd configuration. So this is the Auditd configuration that I want to use. So generally, you have an Auditd module, we're resolving everything, and then we are defining the rules. So these are the same rules that you had for classical Auditd, and we're just reusing some of those. The most relevant ones, or some that we will run into in the demo today, is we are checking everything that affects identity. So we're just keeping track of any changes to identity files. We might check, for example, if a specific user is trying to access a specific file. So for example, I have created a user who can read a specific file, but if he does, it might be a weird sign, and we want to keep track of that. So just to show you that, let's use that user. We have an elastic user. By the way, what happens if I'm using a password is just for the demo, never use a password for SSH. What happens if I use a wrong password? We can also collect those informations. So for example, if I run those, after 3 tries, it will just fail, and then we can check what did that user try, or how many SSH login fails do we have. Basically, we have collected the auth log. There is the var log auth log, which we have collected. And here you can see in the last 12 hours, those are all the failed or invalid login attempts. And you can see which SSH login attempts were successful by publicly or by password. So for example, you can see here my Elastic user. Let's switch to the last 15 minutes for now to see that we have an Elastic user. Somebody tried Ubuntu to log in as well. Looks like somebody from here tried to log into my instance, which is totally fine. Just don't run a denial of service attack against my instance. I'll give you the credentials afterwards so you can actually play around with that and try it out yourself. And you can see here, somebody tried Ubuntu a few times. My Elastic user has also just failed. if I click on the Elastic user, everything will be filtered down to the Elastic user. And you can see here we have failed to actually log in. And it was just like, okay, my IP address, which seems to come from Austria, and with the current timestamp, so we are, 25 minutes past the hour, for example. This is what we have here. Okay. So just a quick check, since normally this is the fight between China and Russia, who has most failed login attempts, but maybe not today. Yeah, it looks like China is still leading. Russia seems to be asleep. Like somebody from China tried to log in, something like whatever country, Vietnam or whatever that is, somewhere from Saudi Arabia or so. And then a few people from around here tried to log into your instance. And all of that is in the auth log. Whenever you have a server with something that exposes SSH, you probably will have a lot of login attempts on those, and you can just keep track of those. Okay, but that was just a kind of side quest. Let's log into our user and see what we're doing. So for example, our user is kind of curious to explore the system, and he wants to figure out like what do we have in etc that looks like a password. And then you see, oh, password. And actually, I have read permissions on that, so I can just take a peek of what is going on here. So I can do etc pass. And then the user just reads those, which is fine. But maybe that is not a good user that is starting to poke around our system, and we want to keep track of that. So the rule in our system that we had was this one here. So what we get is we'll monitor that event, and then we'll tag it with developers passwd read. And we can actually just search for that one. So if I head over to Discover, so the dashboards, those are just pre-built dashboards. I didn't create those myself. I'm kind of lazy. I just reuse what I have. But in Discover, you can basically filter down on the actual data that you have in your system. So here, the last 12 hours are probably not good. I just want to see the last 15 minutes. And if my Wi-Fi is not dying, it will work. And you can see in the last 15 minutes, I have collected 290 security-related events. And the one thing I want to see now is I want to see the tags which are from these specific groups, the developers passwd read. And if you filter down on that, you can actually see here, oh, my user has started to read that data. And maybe we're not that happy about it. One other thing, so basically you can see which user IDs and which users, like those are all mapped together. We can tag any event and say, okay, this is a production instance, this is running on AWS Lightsail, and this is basically the violation. You could also write it out to a different tag in addition if you want to filter down on that. You can see the process IDs, the binaries that have been running, and what you have been doing. Some other nice things that we are doing here is, firstly, we're collecting that meta information for the cloud provider. So here, for example, you can see this is running on AWS, and it's a cheap T2 micro instance, but that's all that I need. And you can see the instance ID and the availability zone and everything like that. So you can very easily filter down on that information because you have it in your events as well. The other thing that is kind of nice is that we're automatically enriching the host information as well, if you want to. So for example, you can see which operating system, which version, IP addresses, host names, and all of that information. So you can, for example, know if one specific operating system in one specific version is vulnerable to some security incident or security issue, you might just filter down and see all the things maybe related to that security issue on that operating system to see if something or somebody has been breaking into your instance. So we have collected that one. That worked fine. The next thing I wanted to do, oh yeah. So our user now keeps poking around the system. For example, we say service nginx status. And that will tell me, okay, service is running, is all good. And the user then feels lucky and says like, oh, maybe I just can restart the system. The nginx server. What will happen if I run that command? I'm not a root user, I'm just a regular. I've created a custom developer group, and the user is in that developer group. And the previous command I've monitored was on that developer group. So what is that user doing, or what will happen when I run that command? Guesses? Well, it will ask me to log in with a proper user. Let's say we'll try the Elastic admin. Unfortunately, we don't know the password for the Elastic admin. We can try that. It will tell me authentication failed, and then we can actually see that as well. If we head to the Auditd executions, you can see this one here. This was when we tried to elevate the privileges and run that. So the Elastic user tried to elevate its privileges for that Nginx restart, and we've basically logged that. And you can see we are also keeping track of, for example, when I showed the filebeat configuration with sudo, we kept track of that as well. So anything that people are executing on your system, you can watch and monitor it there easily. Okay. One other thing, my user has a secret text file in his home directory. So I'm in my home directory, and I myself have read and write permissions to that file. What sometimes happens is that you have an admin. You have an admin user. And that admin user is kind of like feeling like exploring. Since that user has root permissions, he feels just like exploring the system a bit. So for example, he checks out what do we have in home. And then he says, oh, we have an Elastic user. Let's see what the Elastic user is up to. And then we see a secret text. Well, since we're an admin, we maybe want to just figure out or see what that is doing. So we run that. Will this work? Obviously not. But since we have root, we can just run the same with root permissions. And then once we enter our password, you can see it's very secret. Is in the file. So if the admin starts poking around your system, maybe you want to keep track of that since he might get valuable data from the users. So for that, we have another configuration here, which was this one here. So basically we have defined the rule. Whenever you're trying to poke into other users' directories, we will log a power abuse event. Let's check out the power abuse. So here we have the power abuse tag. And this is what we have just run. So here you can see then that our user, the Elastic admin, has been reading a file that is owned by the Elastic user and has been poking around here where he should not have. So you can see the Elastic admin, that was the one who ran the command, used his root privileges and caused a power abuse to actually see that file. Don't do that with Auditd. Everything like that can be traced. By the way, we're collecting other things in dashboards if you want to correlate that to events as well. So for example, I've already shown you the SSH login attempts. So those were the last 15 minutes, but we can switch those over to 12 hours. And then you can see, okay, somebody brought out their laptop and tried to log in. Okay, those are the usernames. Was a joke, lols, okay. Yeah, that is kind of what I always expect to see when I run a live demo. You probably can see yourself here. It's always nice if you want to interact a bit and play around. Other things you can see, for example, you can keep track of all the sudo commands that we have been running, which might tell you what we've been doing. So you can see when I provisioned the instance, I ran some installations, like I needed Python, and I ran an update, and I ran all report a few times. So these are all the things that I've been running. Excuse me. these were the commands that we've been running here. You can also check out which users and groups have been created. So if somebody breaks into your instance, maybe you want to figure out which users or groups have been created. So here you can see we have the Elastic admin and the Elastic user. Those were created, their user IDs and their group IDs. You can see when they were created, home directories, which shells they're using and stuff like that. So you basically keep track of what is going on and who has access to your systems, which will also be interesting if somebody breaks in and then starts spawning new accounts around your instances to actually kick them out afterwards or know like which accounts have been touched or what has been created and what hasn't been created. Okay. So I think I've run through pretty much, oh yeah, there's one more thing. Every now and then you have your website. So we have a nice little website. I don't know if anybody has surfed to that one yet. It basically just says hello. And somebody might break into your system and might want to change something. And you want to keep track of when that is happening. So for example, here, let's do, that is var www html index html. So somebody sees that and thinks, well, let's put something not that nice here. Today I won't add any malware. Let's just add an emoji, which VI doesn't support very well, but I think on the website it should work. And then somebody vandalized your website, and you kind of want to keep track, like, why is your website suddenly changed, and when was it changed? Since when have you been serving that stupid thing? To keep track of that, we have in the FileBit module, we have another section down here. Here, basically, we can check for file integrity. File integrity, here we're saying, I want to monitor the var www HTML directory. I want to check files up to 10 megabytes in size, because otherwise it might get expensive. But you can set any arbitrary size. And I want to scan at most 50 megabytes of data per second. And the hashing algorithm that we're using is SHA-1. So basically what we're doing is anything under that path, we are hashing. And as soon as the file changes, we'll see the hash changes, and then we know, okay, something changed, and we at least know when our site was vandalized. You could change that to various directories, and you could also change the hashing algorithm. So SHA-1 is kind of like a good hashing algorithm, but it's not the most efficient one. You could, if you have a lot of data and you want to monitor a lot of directories, you want to switch to some cheaper hashing algorithm. We support like a bunch, like 6 or 7 hashing algorithms, if I remember correctly. So to see what has been happening here, we have this file integrity overview, and this will just keep track of all the changes the last 12 hours, or maybe a bit too much. Let's switch back to the last 15 minutes. And you can see here, okay, something has been changed in my directory. And you can see all of that was in my web folder, and you can see which files have been changed. So you can see since I used VI, there was a swap file. There was an SWX file as well. We changed some. Okay, there was a temporary file and then the actual index file. So these are all the files that have been changed, and you can see what was deleted, what was updated, what was moved, what was changed. You basically just keep track of any changes to our website. And then you can figure out later on, okay, why are we suddenly serving malware or some other stuff that we didn't really want to bring out. So while the Auditd only supports Windows, only supports Linux, the file integrity module supports pretty much any operating system. We just, depending on which operating system you use, we're using different mechanisms to actually keep track of what you're changing. So we have iNotify for Linux, FS Events for macOS, and read directory changes W for Windows to keep track of those changes. Okay. I've shown you those as well now. We've also seen some other dashboards. I think we've seen enough dashboards. By the way, you will get the chance to figure out or see more dashboards on your own afterwards as well. The one thing that I'm kind of keen to point out to, at some point you probably don't want to define your rules manually anymore, because there are a lot of things changing and you don't really know what is going on in your system. We have a component, we call it machine learning, actually is anomaly detection of time series data. So it basically just tries to find anomalies. Which looks something like this. So for example, this is not security related, but these are visitors to our website. But these could be, for example, people logged into your system at one point in time. And then you could figure out, oh, somebody has broken into a couple of user accounts and logs in at times when users shouldn't log in. And here you can see, for example, we have like a daily pattern. So here we have 3 days, and then we have a weekend where we have fewer visitors to our website. And then we have 5 days again, and then we have a weekend. And our algorithm learns after approximately 3 iterations, which is kind of like not so nice because you can see we have 3 days here. And then it started to learn the pattern here, like the blue shade in the background, that is what is the expected value, basically the baseline. Here it started to learn the baseline, but then there was a weekend and that threw it off. But you can see after 3 weeks, it also can predict the weekend. And then it basically over time just learns what is normal and how many people should be on your system. But that could be also traffic to your system, file accesses, how many people are even logged into your service at one point in time. So as soon as something is kind of getting out of the ordinary, you know, either your system is down because nobody's connected anymore, or maybe too many people are connected because some Russians broke into your service. And then you might want to be alerted as well. For example, here we had an anomaly that was February last year. That was when AWS S3 went down. And that was basically when that killed our own website as well. But in the end, nobody complained because the entire internet was down on that day. So it was fine and nobody cared. But the system just learns over time what is to be expected and then can alert you and tell you, okay, here, for example, the traffic was 17 times lower or 11 times lower than what I was expecting. And it could do the same thing for users or any interactions or anything that is happening to your system to get alerts for that. Only downside is that is how my salary is being paid. So that is a commercial feature. Okay, to wrap up, I always compare our stack a bit to Lego. You have all these building blocks, but you need some assembly. And we try to add more building blocks over time. So for example, Auditd was added like 8 months ago or something like that, or maybe even 12 by now, because we just felt the pain that Auditd is a great system and we wanted to get those security events, but it was very painful to parse them. So we didn't really want to do that. And then we just created our own beat, the audit beat, to collect those events. And we're doing the same thing for lots of other kind of events. So we've taken a quick look at Auditd and what it can do. We have practically tried it out with Auditd because it's easier to centralize. And then we have seen some other logs and dashboards around other security-related events that happened or might happen in your system. If you want to try this out now, you can go to dashboard Xera WTF. I'm using WTF because I think for a demo that's always the right domain. If you want to try that out, you will be logged in automatically as a dashboard only user, so you can only see the dashboards. You cannot delete data, you cannot create anything new, but you can see the dashboards and play around with them. And you can also filter down on the data and just try stuff out. If you also want to SSH into the box to cause some violations and maybe see them in the dashboards afterwards, you can go to elastic-user at Xera WTF, and the password is secret. I let that run for today. I'll probably kill it tonight. Please don't start mining bitcoins or anything. But it's a very small instance. You won't get very far. You won't get rich, I'm afraid. You can just try some things out, see the dashboards, and yeah, just give it a go if you want to wait for lunch a bit because there might be a queue. If you stay here to play around with it, maybe you can avoid the queue. Just a tip. And with that, before I forget, I have a couple of stickers right here, which might be hard to see. If you want stickers, we have loads of those in every color and shade. You can stick them on your laptops, kids, co-workers, whatever. Get stickers. We're always happy to hand those out. Are there any questions? I guess we can have some light again for the questions. Oh, by the way, if we can have some light, I always try to take a picture so I can prove to my colleagues that I've been working. because they don't know where I am normally. So this is my way to show that I've been working today. Smile, everybody. Very good. Questions? Or shout and I will repeat.
Auditd namespaces and containers, are we actually going to, in any kind of near term, be able to get visibility into containers in a way that we can do the types of things that you're showing us here, or should I get a different job?
Yeah, container security is, let's say, an interesting field. I don't want to lean out of the window and say now, oh, everything will be good, because container security is kind of hard and is also very much emerging. And then you throw in Kubernetes and everything is twice as hard. I don't think we have found a silver bullet yet, or anybody else has. We will also work on that and try to improve around that. But if you can avoid containers for security-related things, it would probably be easier for you and everybody else. But no, I don't have a good answer for that, unfortunately.
So your advice is stop the train.
No. Don't stop containers. It's just like, if you're very security conscious, be careful. Don't run everything as root. Like, we see that quite frequently, that people want to run everything as root in containers, for example.
Sure, I mean, there's container security, but I mean, I guess I'm specifically concerned about namespaces and Auditd compatibility with namespaces, and just, I mean, they're a black hole, right, to a great extent right now, and so.
For now, they are.
I don't like black boxes.
I'm not sure if we are the ones to solve that, or if you need to open a pull request against the Auditd repository.
Yeah, I mean, it's the community, right? Like we have to say, hey, we have these tools for monitoring, and you're not letting us monitor anymore. And then there's making pull requests against the kernel to fix things, right?
Yeah. But I'm afraid I don't have a good solution for that today. Obviously. I'm sorry. Any other questions? Questions? Should we take a quick look to Slido? I hope there's nothing too bad in there, because it's unmonitored, so you never know. Ooh. How much configuration went to the Auditd before it was usable? You mean the system Auditd that was pre-installed in my system? I didn't touch any of those configurations, to be honest. It was just monitoring some events, but well, again, if you want to do any configuration around those, these are probably the baseline rules where I would start, and then just put together whatever makes sense for you. I'm not sure that answers the question, but I hope it does. How do you protect the system from data flood? For example, a malware could create easily tons of events. That is indeed true. As long as you're shipping them off your system, then the problem is kind of on the monitoring side for Elasticsearch. We do have some tools to actually keep track of how much data you have. So Elasticsearch, for example, will reject writes at some point. Or you can just rotate indices with that data. So you can get rid of that, but obviously the kind of relevant data might be drowned out in all the noise that something is generating. So there's no easy solution for that, not having too many events going on overall. We would need to have, for audit beat, to have a discussion around how does Elasticsearch scale around data. We can totally do that, but I guess it's not really the focus of this talk. For Auditd, well, yes, it will flood your disk, but you probably have, or hopefully have, a rotation configured on that so it won't fully take over your disk at some point. That's, I guess, the only thing that you can do. And last question, since we're really out of time. How do you secure your Elasticsearch Auditd server? So, everything I've shown so far, in the open source version, everything is open. Um, we do earn our money with security-related things, but for example, since I was using our cloud service, you can see it here. Here I have credentials. So this will be TLS encrypted. We have usernames and password. But yeah, if you're using the open source version, you will need to do encryption on the wire with TLS or a reverse proxy yourself. Since it's all HTTP, it's pretty easy to do. Just use Nginx whatever to terminate TLS in front of Elasticsearch and do basic auth, and then you have a reasonable security setup. And I guess we're out of time. Thank you very much. Enjoy lunch.